You can see the record button right now, right?
Yes.
Okay, so it's officially started. So today we're going to talk about time series and how we could train a ARIMA model, a profit model, and all the base models that you learn in the class. So basically, the data set is a data from Bixi. I assume you have some assignments about the Bixi data set. I'm not sure. So it holds a data including some time stamps, and it shows at what time, at what date a member of Bixi has used this service. So the Bixi company is very interested to estimate the demand based on these historical data, because it's pretty important to them, because they need to find out exactly when the demand is going to increase. So what it's the peak time for their services, so that they could schedule the staff just like the services, or maybe they could redistribute the bike centers. So this is why they're interested to know how many departures takes place in a given time slot, which is in our case. So this is why we're going to train time series on these data sets. First of all, just like always, we need some packages, so we need to import them. Like pandas, we would need profit today, because this is the package you're going to use to train a time series model. Matplotlib, like always, also datetime package, because we're going to work with datetime data, and NumPy and mass. Okay. So I explained about this data set, which is from Bixi, and why they're interested in this. So the data that we are going to work with is in their website. Actually, it's you could just access to this freely, and you're interested in year 2019. So you need to, in order to have access to the data, you need to go to the website and find like there's a year section, I think. Yes, year. There's year. So under year 2019, there is trip history. You could download the whole data set for the whole year, but we only need August, September, and October. So there has to be 3 CSV files under these names. So you need to download them and then copy them in your Google Drive if you're working with that collab. Okay, so I will give you a couple of minutes to do that if you would like to run your code just simultaneously. Hey Nima, I saw you here. Good to see you.
Hi, Ziva. Thank you. Hi, guys. I think we have Negar, Aydin, and Hania. It's good.
You know them, huh?
Yes. Yes, all of them are here. Thank you, Ziva. I want to join to your lab because I want to learn more about the time series. Thank you.
I hope it's useful for you.
Yes, thank you.
Good. Okay, so if you have already downloaded the data, just please copy it in your Google Drive. And after that, be ready to drive mount to our Google Drive files. Okay? Perfect. Just let me know if you still need more time. I'm just going to move on. Okay, so as I told you, there is 3 different CSV for 3 different months. And after just doing a drive mount, I could have access to the CSV in a Panda data frame format. Just to see what's going on in this data set, I'm going to print 5 first rows and 5 last rows to see what's happening here. So as I told you, there is timestamps, which is a start date, the exact same origin that's like the members took the big C, take the big C, and also the departure date and the departure place, the destination. We're not paying attention to the destination and their end time. The only things that matters to us right now is like the departure, when they take the bike and at what date and at what time. This start date, it's actually a date time. So just because it's doing the printing, you don't see it here, but you could see like here. So there is both hours, minutes, and second, and also the date for the departure. And they are interested to know the early bike departure. So if we look at this data, this is not what exactly we want. So you are just seeing the trip information for each person. So the thing is that there might be several usage in like a 1 hour, and this is exactly what we want. So there is a pre-processing step before we could train our time series model, which is what we need to do some step to convert this data set to what we want. Like what? We want to see how many usage took place for each hourly time slot at each day. So basically, I have 3 months. At each month, there are 24 hours. No matter what is the second or the minutes, I just want the hours and the number of usage of bikes. So to do that, I need to round down the second and the minutes to the nearest hour. For example, if I have like 7:55:22, it's going to this exact line of or row of data is going to line 7 hours, 7 o'clock. So this way, I would be able to count them. So to do that, there's just simple steps to do that. Going here. First, I need to show you something. So far we have the Big C 2019 data that I think I forgot to mention that when I upload the data, there was a concat like function to just stick all the 3 months together. So I end up with the overall data set, including these 3 months. So we called it Big C 2019. So here, and we saw the Big C 2019, including how many data, I don't know, I don't remember. But about start date, I just wanted you to see this. Oh, just let me do that one more time. Okay, in here. Okay, now that I upload the data type is object. And do you know what object means for a data frame? So what is actually the data type of the items here in this column? When it said, I want it to be date, but it's not, because it's showing object. An object in a data frame reflects a strings.
Yeah.
So it's basically saying that this is the type a string. And if I'm going to do some manipulation based on the date time data, I need to convert that to date time. So remember, if you're going to use some functions like replace here, replace is a function only for date time data type. So I need to convert it or change it to date time. So the first thing. The other thing is I have a column including all the the departure date, the start date of the trip. There is a date section and there is a time section. What I was going to do was to round down the minutes and the second to 0 and to make it change the nearest hours. So there is a function for that, which is replace. By replace, I told you, the replace function is going to be applied on a date time. So it will take your date time, and as I mentioned here, it's going to change the second to 0 and minutes to 0. So it only keep the hour. And what is this? This is exactly the apply function that we talked about it so many times in Panda pre-processing tutorial. We talked that apply is a very useful function when you're going to do a lot of manipulation on all the cells, all the data in a columns in a data frame. Apply would be a very good option because it's actually of order of magnitude of 1. So in only one step, it's going to apply a function on all of the data cells in that column, okay? And what is the function? This is this function. By the means of lambda, I'm defining a function to do what? To take something, take an argument, and replace the second and minutes by 0 and return this. So this is my function. By apply method, I'm applying this function on all of my data rows in a start date, okay? And actually, all of this is done after converting my data to date time, okay? So it is not a string anymore. So from here, from just like left to right, this is date time conversion, and then applying the function to do the manipulation. All good? So also I'm storing like a start and end date, which is the minimum start date and the maximum start date, because I'm going to need them in the following. What else I need to do? Just let me do these 4 steps before moving on to see what's happening here. See? So it's just changing the date. And after that, I asked it to print the data types because I just changed it to date time and I wanted you to see that. See here, it's date time. It's not string anymore. Okay, and I'm also storing a start and end. I remember putting a print somewhere here. See? So the minimum date time that I already have is starting August 1st, and I have it until October 31 at 23. So I need it later on because I'm going to generate some date range to do visualization, okay? Just have it in your mind. Okay. After that, I would like to see the data so far. So what is it like? Let me print it. Why I don't see the time? Okay. See, I only have hours. I got rid of second and minutes. So I have one step remained. Any idea of what would be the next step? I told you, I just wanted to know the number of trips that have taken place in each hour. So I need to aggregate this data, and group by is what makes me able to do that. Okay, so I will use group by method and the grouper from pandas to pass the column that I'm going to do the group by on, and by which frequency. My frequency is hourly. So basically I'm telling that I need to do a group by on my data frame on the column start date, and the grouping would happen on each hour because the frequency is h. It could be other things. You could look for other parameters like d as days, like m as minutes in like documentation. After doing the group by, I would need to aggregate them. But how? By counting. So this part is basically saying that count all the data in each hour and put it in the new column, which is called start station count. Okay, so line this, I would end up with a very different data frame, just like this. So I have the count of, or basically the number of usage of each different bytes at each time slot. Okay. There is also another problem that needs to be solved here. I don't want this to be index, because you see it's an index column. Why? Because it's placing a little bit lower than the column names, and also it's the first column, so it is index. I don't want it to be index. So I need to reindex the data and then reset the data frame to have the correct index, okay? I did that here. We'll get to that. So just keep this in your mind. Okay. Before that, I'm going to generate a date range. There is a date range function from pandas that, remember, we had a start and end date that it's useful now here. So I'm going to generate hourly periods between these two dates, a start and end dates. So I created this data frame, just like, let's see this. It's just a date range. See, just a date range between two like start and end date that I gave it, passed it as the input. And in order to reindex that, I need this, because I would like all days to be my new index. So by doing this, I'm just generating my new index. So reindex is like matching all the data together with the new index. And if the index exists in the data set, that's okay. For the value, it's going to be the same value, which is count in our data set. But if there is no matching index in the new data set, it's going to be filled with none. Okay, so in a reindex, if in the data frame that I'm reindexing on, there is no value, by passing this parameter, I'm asking to put none instead of that. And it's very important to do that, because, and to check for non-values after, because you know that you're training a time series. So for a time series, you need to have a value for all of the data points, data slots. Okay. So I'm reindexing, putting all days as my new index. And now this is my data. I have the column count, but there is no my first column is not my index anymore. And by reset index, I will add the new index from 0 to the number of, like, whatever it is, to the number of data I have, like this. And in place is true, so I will keep that index. So this is what I'm doing, but I need to put drop true because I don't want that. Let me. Oh, what I just ruined. Let me start again because I just ruined my data. Okay. And the group by, it has to be all right. Creating my new index. Let me just get rid of extra steps. Reset my index. It's okay right now. It's okay right now because I have the time, a start date and time as a column and the column for my index. Okay. Drop should be false because if drop is true, this column will be eliminated. So by reset index, I'm just creating the new index column from 0 to equal to the length of the data frame. Okay. So everything is good now. The only thing is that we did all of this to find out if there is a time slot, there is a specific time slot at a specific date, at a specific hour that is null. There's no byte usage in that specific data stamp. So, and this is recognized as null value. So by getting an is null and then getting a sum over that, I could see if there is a null value. And I told you there shouldn't be a null value. If there is something, in our case, there's no null. But if there were anything, it could be a good idea to replace it with an average from the previous time period and the time period after that. And you could do that with interpolate method. Interpolate method will do the same trick for you. If you apply interpolate on the column, because the column that's we take care of, it's a start station count. So if it's null, it's going to fill this null value with the average of 2 adjacent data periods. Okay. So if I run this code, it does nothing because there is no null values. Okay. What else now? Now we did all the pre-processing. So what we saw here is what we were looking for. The count and the start only 40 hours. So my data is ready. There's only one more things to do. If I'm going to use profits, I need to change my data frame in a way that I have new column names. So the only thing that matters to profit is this. It needs two columns. First one is the timestamps, which should be called DS as data stamps. And the second one is Y. It's your it's your values, it's your time series values, okay? That is the count that I calculated with the group Y. So by rename method, I'm going to just change the column names as this. You could see that here. See? I don't have like a start time or index or a start station count anymore. I just have Y and DS. DS is for date stamp, and Y is your time series. Okay, so all done. So far, everything is good. The only remaining part is that, just like any other training model, we need to split the data into a train and test it. Training for do the fitting process and the test for do the prediction. But there is one difference. It's a time series, and you don't need to shuffle your data anymore and randomly split train and test it. You need to just do this sequentially. So the 80% of the whole time series from the beginning goes to the train set, and the rest goes to the test set. So it's sequential. For this task, we are asked to have from August 4 to September 29 as the train set, and the rest as the test set. So we're going to do the exact same thing that this case study requested. So considering this time period, we need to do some filtering on raw data. So as we call it before, conditional filtering. I'm just giving some condition. How? Like this. I want the departure, the Big C 2019 departure, which is my ultimate data frame. I'm going to filter data stamps column that includes date and time. I want those rows that are greater than 29 of September and less than October 6 to form my test set. Okay, so it's just going to split the data frame in two portions, row wise, and the rest is splitting the first section and put it as train, because if it's greater than August 4, as it said here, and less than September 29, that would form my train set. Applying this, also after splitting, because when you split, you have the old index and it's no more of use, because you need to reset your index because they are two separate data frames. And after doing this splitting, you need to reset index. Okay. So basically, I end up with my test set and train set for a time series. So in a time series, one column is time periods and the other column is the value you want. Okay. Now we could do some visualization. Anytime that you need to visualize a time series, because you might have a lot of small data stamps or data periods. So normally x-axis, visualizing x-axis is is like very bad. So if you didn't do this trick, these 4 lines of codes, you will end up with a very ugly x-axis. So don't ask. I really don't know what is the behind the scene of these like methods and classes, but basically what it does is making your x-axis more beautiful, and it only visualize just some points in your data period, not all of them. Okay, and by this min ticks and max ticks, you could change the appearance of it. And after this, I'm going to plot a line chart for my train sets to see how is evolving my time series, especially for my train set. It's not including tested yet. Okay, so my line chart is showing number of departure per hour for my train set. The x-axis would be the data periods, data slots, and the y-axis is my time series, okay? Which was the count. And this is the result. See? So as I told you, on the x-axis, there's only just some particular time slots that you could see visually. It's beautiful. It's not ugly. And on the y-axis, there is the number of departures. And you could evidently see some components or pattern in it. Do you have any idea of like what components you could see in this chart?
You mean that about seasonality or trend? Or
Exactly.
I think that it's seasonal.
Yes, it's seasonal component because there's a seasonal pattern, and it seems it's weekly because like if it's 7 days here and 7 days here, it's just going ups and downs for each week. And maybe there is also a daily seasonal pattern because you could see also a smaller fluctuation. So there might be also daily seasonal pattern. And if you take a deeper look, you could see even a slight decreasing trend. Just like this. It's very slowly decreasing over time. So we expect to see a seasonal pattern or even a trend in this data. And go ahead.
Sorry, I have a question about the splitting the data into train and test.
Sure.
You said that we have some conditions for, I think, the train data, to train the data.
Yes.
And we split it to 2 parts.
Exactly.
So we define this condition according to the details that we have in the question, or always we try to just divide train test to 2 parts. I mean that it's always the same, or no, it will be changed. Maybe we do, for example, we split the train test for more than 2 conditions. Can we do it?
Here we have, there's 2 parts in your question. So first of all, you need to split your data in test and train. So it's clear, you always have to do that. But in whatever condition you want, for example, just like before, we did a 80%, 20% split. So you could consider it number wise, like 80% of the first data goes to train and the remain goes to test. But here, the condition, which is like, there is an and here, because this is what they asked us to do. It's not always like that. So they're asking to consider all the points between August 4 and September 29 as your train set. So I I have to put a condition here to filter the data. How? In a way that I will have all the data rows, which is like greater than August 4 and less than September 29 as my trend set. So this is the condition that is applied here in this specific example. But always you need to split your data. Okay?
Okay, yeah, thanks.
The only difference is that before you need to shuffle the data and randomly split the data, but here, because that's a time series, you don't need to do that. Only remember to reset your index after splitting, and that's it.
I see. Thank you.
Good. Okay, so just like we discussed, it seems to have a daily or weekly seasonality, okay? Or maybe a slight trend. But how we can confirm that? We know there's a way to confirm this, which is autocorrelation. With autocorrelation plot, you could confirm your visualization. And just one more thing, whenever you're going to do time series, don't do visualization plots just like this, line plots for your test set, because it may give you some bias about your decision, because you visually see something and you think it's going to be 100% true, but normally it's not. So only consider visualization for your trend set. So I was talking about autocorrelation. Autocorrelation plots is a way to confirm your just like guess about the component. And hopefully there is a autocorrelation plot function that you could use in order to plot that. This is for pandas, so I need to import the package. And then the input for autocorrelation plot is just a series. It could be an NumPy array. So I just need the values of my time series, which is the column Y from my train data, and I'm converting it to a NumPy array because it's just one series, what autocorrelation wants actually as the input. So preparing my input, and then I will pass it through autocorrelation plot, and I'm giving it a title, and this is what it is. Okay, so from this autocorrelation plot, we are out of our confidence region. So definitely we could say there is components. Because of the fluctuations, there is seasonal components. And because of the trend you see here, there is a trend in our time series. Okay. The next step is to train baselines. We had four baseline in our lecture, which is mean baseline, naive baseline, seasonal naive, and drift baseline. In order to just do this baseline, we might need to do some like calculation for the parameter for M, K, H, and we're going to do that. Just for simplicity, we're defining a new data frame to keep all of these baseline as the new column, just stack new columns for each baseline to this data frame, which is pred. Okay, so I'm creating a new data frame that has the exact same data stamp column from my test set, because I'm doing this baseline for the test set. It's only for the prediction purposes. So I'm taking the test set, which column? The data stamp column. I'm generating a new data frame, which is called pred. After that, again, I need to reset index because there is no index for this data frame. In the next step, I'm going to calculate H maximum. What is H maximum? The maximum number of periods that I can predict. My prediction is for a week. Okay, so, and the frequency was hourly. So I have 7 days a week, 24 hours, and plus 1, because that would be the last period, the very last period that I could predict for. Okay, so each H max. There's also YT. YT is basically the last data in your time series, which can be done like this. You could take the len and minus deduct the 1 because of the indexes in Python, because the index is not including the last number. And also I need the first data, which is Y1, so the very first data with index 0. I want the len of my time series, my train set, which is T, the total number of time periods that I have. And I need M, and M is showing my seasonal pattern, because we guess that there is, not only we guess, but also we saw in autocorrelation that there is a weekly seasonal component. So I will define it as M. Remember, the frequency is H, so I need number of hours per week. Okay, so now I'm equipped with everything. I'm ready to do my baseline models. So the mean baseline is taking the mean over all of the data point in your train set. So it's very easy, just having my time series value and then taking a mean, storing this value in mean baseline column in my predict data frame. So far, if I see my predict, like the very few first line, it just only have mean baseline. And this is my time slots. And this is actually for my test set. So don't be confused. Is using the average of the train set to predict for each of my test data points. Okay. What is next? The naive baseline. The naive baseline is taking the last data in the time series as the prediction for all the test set. So this is what it is. And the seasonal naive baseline. The seasonal naive baseline, both seasonal and drift method that we're going to see later, they need to be calculated in a loop, because you need to do that for all of the period after the last period, which is YT. So basically you do that for H equal to 1 to H max, but because it's the range and it doesn't include the last one, so you need to do H max plus 1. Okay, so, and after that you calculate K. From this you calculate the index just like in your lectures. Drift method, seasonal naive baseline. See, if you want to predict for any period after T, so H could be 1 from 1 to H max. For us, H max is like after 1 week. Okay, after 1 week, which has 7 days and 24 hours. So I define H. There is a need to define this whole index. So T plus H minus M multiplied by K plus 1 is actually my index. I'm calculating it here. And after calculating it, I need to pass it through my train data set. And as Python, again, the indexing for Python, I need to subtract 1 to get the correct index, okay? And in each iteration, I'm appending this value to a empty list I call pred list. By doing this, I would end up having a prediction based on the naive Bayes model for each of the time slot in the coming week, okay? There is a coming week after a train step. So let me just run it. And now if I again do the spread data, see, I would have naive baseline, mean baseline, and seasonal naive baseline. So calculating seasonal naive baseline is a little bit trickier than the other two, which was very simple. And this is actually the same procedure, not just like the process that you need to calculate it in a for loop for each of these time slots, but with a different formula that you had it in your material, class material, okay? But this is doing the same. So let's see.
Sorry, I have a question.
Sure.
What this number exactly shows? I mean, 674 that we have with for naive baseline.
This is the last data point in your training.
Train.
Exactly. See?
I see.
In your example, this is the training step. And this is the last data. So for us, it's gonna be September 29.
I see. And then the model is going to predict the other data based on this data.
Exactly. It's going to put a same prediction for all of the time period in your test set. So this is why it's called naive, because they're going to just put the last data as a prediction for all of them. Okay?
Oh, thanks.
And mean, instead of putting the last data, is just putting the average.
Average, yeah.
Right? But seasonal naive and drift model is a little bit different because they are just dynamically changing. It's not constant. And you see, it's not a constant value for all of them. Okay?
Okay, thank you.
Okay. Moving on. So we also calculated drift baseline. So we have all of 4 baselines here. And there's time to just plot them. I'm going to plot them just like what we did. There is one more difference here. So I have the train data, the data stamps or the data slots, and also my time series values for the train. And I'm adding prediction for the train set and for all of these 4 baselines, as well as one more thing. No, I'm not adding test set here. And that's it, just let's see. So this is the train set, the blue lines that we already saw before. And this is our estimation for the test set based on 4 base models. So the orange line is the average. The red is the drift, because we saw there is a very slight decreasing trend, and drift model is basically connecting a line between the first and the last data. So this is why you are seeing a very slight decreasing trend in the drift. So the green one is the naive, which is the very last data here in your training set. And the rest is naive seasonal. Naive seasonal is different because it's just imitating the last seasonal pattern for all of the periods, for all of the test periods, okay? So, and I just wanted to tell you there is alpha here, 0.3, because it shows the the transparency of the line. I just wanted to be less clear. So this is why we put alpha 0.3. Okay. This is dashed with less clear. Now we can move to profit to see how profit work. And profit training model, again, just like other models, we need to create an object from profit class, do the fit, and then predict. There's a very small difference I will explain later. So first of all, I'm not sure if I told you, but if you're going to try this on your Jupyter notebook, even on your Colab, you need to install Profit. So just go with pip install Profit in your terminal or even here in your notebook to make sure your Profit package is installed. Okay, and after that, you could use this line of codes. So I'm initializing the object from Profit class, which is called M, and then I'm calling the fit method on this object. Okay, the fit method is applied on the train set. Don't remember, just like always, fit on the train and predict on the tested. Doing this, my model is trained, my profit model is trained, and there is something mentioned here which disabling yearly seasonality. It's very obvious because we saw that our data only includes 3 months, so it's just very reasonable to do not include yearly seasonality. Okay. This is the difference that I mentioned with other learning models we saw. In order to predict, before doing the prediction, you need to create a new data frame by this make future data frame method. So there is a dedicated method for this to generate a data frame. We call it future. There is two input parameter for that. Periods. Periods is the number of period that you have in your test set. So it is 724 like this. And the frequency is RLE. So you need to define that. You need to define your number of periods that we discussed. It's H max, the number of periods that you're going to predict for, okay? And the frequency, which is RLE. So by this, you're just generating a data frame called future, nothing more. After generating this future, and just let me show you what it's like. See, that's a data frame with the length of H max, and the first column is your data stamps. So this is the data slots, data periods that you're going to predict for, okay? So now it's time for predict, calling predict method. So you call predict method, give the future as the input. So pass it as input, you could have your forecast. In forecast, you could see the columns in forecast. Forecast is also a data frame, including a lot of columns. I honestly don't know many of them and don't know what they're doing actually. The only columns that are very important to me is y hat, which is my prediction, y hat lower and y hat upper, which is a lower bound and upper bound for your estimation, for your prediction. So it could form estimation interval for you, okay? So in this forecast, what is important is that just I told you, is the data slot columns and my estimation, okay? So far I have the estimation, the prediction, also from profit model, as well as my 4 baseline model. So I can just plot that. Like what? Only for test set, actually. So I have the x-axis, which is again data slots, my time series from the test sets. This is my real data. Okay, so I'm showing my real data as a small red dots, but in order to plot your forecast, your prediction from profit model, there is a plot actually for this. So the plot function, the plot method is for the same package. So you don't need to do anything else. So just use plot function from this package and pass your prediction, which is called here forecast, as the input. So this will plot my forecast. This will plot my real data in the test set, because remember, my test set is not a out of sample data. It's just a real test set. So I had the Y values for each data slots. And these are just the titles. So this is what it is. So profit will give us an interval. This is why you see an interval here. So there is an exact prediction, which is the dark blue, and the light blue is for the interval. And the red points is the exact values, the true values for the test set. And this is the train set. Good? Okay. Now, okay, let's see. There's another interesting plot from the same package, which is called plot components. Plot components will show you the components that you already guessed about. So based on my prediction for the test set, I don't care anymore about the train. So what I'm looking for is to see if there is any component in my test set. So passing forecast as the input, I will end up with these 3 beautiful plots. So this is a decreasing trend in my test set. This is a daily pattern, daily seasonal, and I'm sorry, a weekly pattern. This is weekly, and this is daily pattern. So just like we guessed, also in the test set, there is seasonal pattern, both weekly and daily, and there is a decreasing trend. Okay, and this is the default options for these plot components. I think you could also change them. Okay. Now, how we could realize which model is acting better? So again, just like before, we need to calculate the error. We need to have a matrix to compare the performance of our models. You could do this on your own, or you could use scikit-learn metrics to use the pre-written metrics. Here we're going to calculate MSE, mean squared error. So to find out the error, you need 2 inputs: your true values in the test set and your prediction. So we are going to calculate MSE, mean squared error, for all of the 4 baseline, mean, naive, seasonal naive, and dirt baseline, as well as the profit model. So 5 lines of code, almost the same, just the prediction is different. So I'm giving as the input the prediction of my test set, and because I do have the true values for my test set, I'm able to calculate the MSE. And if I calculate the MSE, I would end up with this result. So comparing these 5 methods, I could see profit is awesome. Profit is giving me like the best MSE, the lowest. And after that, naive seasonal is a better option because we saw there's so many fluctuation in the data, especially a very big seasonal pattern. So it's better to use seasonal baseline, not, for example, mean, not a naive baseline, which has a very large MSE. Okay. Okay. The last point is that we do this to be able to predict out of sample data, the data that is unseen to us, because we only care for generalization. Okay. So in order to do that, we could consider all data sets, including test and train, as our new train set. So we could just do not split things because we already know, for example, profit is the best one. So we could use this result to apply the model, the best model, on the whole data to see the out of sample prediction. So here, I'm again generating an object from the profit class and then do the fitting process on the whole data without splitting. So this is my data before splitting. It includes all the data. And after that, I'm going to predict for the next week. So if it was, I remember it was until October 6th or October 31, I don't know. I think it was until the last of October. So we're going to, out of sample data would be a week after that last date, okay? So again, Hmax, because it's gonna be a week, and with hourly frequency, so I'm generating a data frame called future with the same periods and frequency, and I'm doing the predict on this future, just like what we did. The only difference is that we're fitting the model on the whole data, okay? And then you're able to plot that using the plot function from the same package. And this is the result. See? So yes, it was the end of October. And after that, I'm going to predict for the next week after end of October, the train set and the prediction. Okay. And also the component plots. Okay. And that's it. But we are now ready to do ARIMA. I will share the code with you. Where is my chat? So, everyone in the middle. Okay. I'm sharing the collab file for ARIMA model. Okay. You know what ARIMA does? So ARIMA is basically an autoregression model that based on a level of order, I could say it's called order, but I'm not sure about the exact term. Just to be sure. Yes, order. So it could be of order P. So P is defining the number of data that is the number of predictor that is going to be involved in the regression process. So if you're going to use autoregression, the big question is this: what would be P? What would be the best order for a model. And hopefully there is a package called PMD ARIMA that could use an auto ARIMA for you. And this will actually do some calculation to find the best fine-tuned hyperparameter for you. So it will automatically find the optimal P for you. And having the optimal P, you could just train your model and enjoy the result. So there's no need to do hyperparameter tuning on your own. So what is basically doing here is to call AutoArima function from this package PMD. The complete name is PMD ARIMA. So after importing and installing the package, I'm calling the AutoArima method. This method is giving the train, is taking the train set as one input. Okay. Why train set? Because we're going to train the model on the train set, and the whole goal is to find out the optimized parameter for this model. So we are giving the data, we are passing the data as the input. Also, we are passing seasonal equal to true. Why? Because we already saw there is a seasonal pattern. So we are putting it as true. And if you put it as true, you need to define your season, your seasonal pattern. It could be weekly, it could be daily with like frequency of hours, anything. But here, I'm passing an M. An M is equal to 24. Why? Because behind this algorithm, there's a lot of calculation. So if you're going to consider a weekly pattern, it's going to take a lot of time. Also for this, that I consider a daily pattern because we saw a daily seasonal pattern in the Bixi data set. I'm calling it 24 hours. It means daily pattern. And only for this, it's going to take like roughly 20 minutes. So it's going to be time consuming. If you're not willing to do that, you could consider n fits equal to 10 or a lower number or even more. N fits is the number of times that the model is going to be trained to fine-tune the parameter, okay? So by doing this, you're going to decrease the computational time. But of course, having this line would give you more precision because the number of iteration is more, okay? And by trace equal to true, you are asking to see the logs of optimization. So you're basically seeing this result. And the objective function here, which is minimized, is AIC. That's, I don't know how it works. So after training this, it will give you the best parameter for the ARIMA model. Here in this case, it's suggesting ARIMA 5. So it means that the order of this model in the best case scenario, it's 5. So if I take a summary from this model, I will see the information, like what would be the intercept and what would be the coefficients of each of 5 predictor, like here. See? So my prediction would be on the 5 previous data points, and this is the intercept, and this is the predictor weights that is here, that's shown here for each of these data, okay? There is also a very interesting plot diagnostics, that shows you residual plot. So visualizing the residuals gives you a sense that, okay, that's having a standard normal distribution that is just hovering around 0, which is what we really want for residuals, okay? So doing all this, now we are ready to predict because we already fit the model and we know what is the best parameter. So we could just take that model, which is the object we already initiated, call the predict method on that. And you also need to give the number of periods in your test set, just like what we did in Prophet, as the input. Okay? And if you do that, you will end up with 2 outputs. Predicts is the prediction value for each period in the test set. And the second output would be your intervals, the lower and upper bound for the prediction. Okay? So I'm putting these prediction in the PREDS data frame we already have. So as AutoArima new column. So stacking new column AutoArima to the PRED data frame that we have. So this is the result. The same data stamps that we had in the test set, the mean baseline, naive baseline, seasonal baseline, drift, and the last is AutoArima. Okay? It's all of them are the same, only Prophet is not here because it's a different like Google Colab, and there's no Prophet model here, but everything is the same. Okay, so just like what we did, we need to again calculate the MSE error to see how is AutoArima performing. So if I do that, I will end up with MSE from AutoArima here. So it's almost double with double of Prophet. So it's not that good, but still comparing to other ones, that's okay. And very close to the naive seasonal baseline. So basically, naive seasonal baseline is acting pretty good. Okay. And the same plotting again for the ARIMA, model, just like what we did in the previous collab. Okay. Now here is just like the last part in this file in ARIMA in Prophet that we did an out of sample prediction. So we are going to do this here. Train the model on the whole data set, including all 3 months. Fit the model, okay, and predict it for the following week. So the following week is not included in the test set that we split data. So we consider the complete data for the training and then forecast the values for the coming week. And just like what we did in prediction, we need the number of periods. And as the input, we got 2, as the output, we got 2 outputs, which is the prediction and confidence intervals. Okay. So for visualization purposes, we are just generating a date range for the future period that you were talking about. So I told you it's going to be after end of the December, so November 1 until 1 week. So we're just generating the dates by Pandas date range and use this as the axis here to plot the data. Okay, the rest is almost the same. And also here we are also plotting confidence interval. So the first column is the lower bound and the second column is the upper bound with the lower transparency. This is why you see something like this here. Okay, so this is the predicted values and this is the intervals. And that's it. That's all. So just as a summary, what we did was modifying the Big C data that was including the start date of a trip in different time slots within 3 months period, and also the end date of the trip. We were interested to know how many usage of Big C bikes has happened in each early slots. So we did some pre-processing to prepare the data. After preparing the data, we modeled 4 baseline, profit model, and ARIMA model. We compare these 6 models with MSE metric, which is mean squared error. And we finally saw that profit is the best among them for this data. It might be different for another data. And among baseline, seasonal naive baseline was perfect because there is an evident seasonal pattern in our data. And that's all. If you have any question, I would be happy to answer. Otherwise, we could end the session.
Thank you.
No problem.
Okay, I have just another request from you, you know, because I have a personal data set and I just have some problem with that. Can I have some meeting with you in person to just consider my data set and ask you some questions?
Okay. I would be happy to help, sure,
Mhm.
but I'm not very, just let me stop
Okay, thank you.
because
Thank you. Bye.
bye-bye.